This video is to show how to connect the Hertz experiment devices. So this is the neon tube, and basically inside you see the grid and the neon gas inside. And this tube is connected with computer, and this computer analyze the data, and the data we can see the signal, we can see the data from the computer. There another computer using the Vernier software. Okay, let's see how to connect the neon tube and the device. So let's start with the neon tube, and there are 4 connectors here. Left cathode, and this is the cathode, heater, and anode, and the control grid. So cathode is connected with the computer. There is a K here. This is connected with the cathode of the tube. And the heater here, this is connected with this H. This means this is connected to the heater of the tube, and so you can adjust the potential provided for the heater. But usually we don't want the voltage. You want the voltage to be high, but not too high. So the heater usually up to like 10 volt. And then the anode of the neon tube, that's connected to the A here, and there is so basically this is the potential we're going to use to accelerate the electron emitted from the heater. And the last one, this white cable, and this is connected with the control grid, and the control grid 9 volt here, and that's it. And okay, so the top, this black BNC cable is connected with this M signal here. So basically the signal enter the computer here. And then we want to use that computer to see the data. So now this side you have 2 signal out. One is the accelerated signal. So this is suppressed by 10 times. So here we provide up to 80 volt. On the computer you will only see up to 8 because it's divided by 10. And then another signal, this is the Y signal. This will be the signal of the electron after the collision. Okay, and so on the computer, when you open the Vernier software, you have potential 1 and the potential 2. So potential 2 is the Y, and the potential A is the X. X is the accelerated signal, accelerated original potential, and this is the potential after the collision. Okay, and next, let me turn on the device and see how the signal looks like. Okay, so you see a flare over there. Okay, so next I'm going to manually adjust the accelerated potential anode. I'm going to start with maybe 20 or 30. And next, let's look at what happened to the neon tube here when you adjust the potential. So you see the filament. Now I'm gradually increasing the potential. And you see that when the potential is high enough, you see a globe inside. Now that's one layer. Now I'm going to continue increasing the potential. This is very hard to show the signal on the computer, on the cell phone. So the software is just the Vernier software Logger Pro. Okay. Now we have 2 potential, and so let's adjust the axis. So this one is the potential 1. This one is the potential 2. Okay, I want to adjust the time here. Let's make it longer, 60 seconds. 60 seconds. Okay. Another option, I'm going to change the graph option. I don't want to see those lines. Okay, now let's see. Okay, so basically, this device, there is a two menu. You can manually change the accelerating potential if you switch to the left. But we're going to use the automatic 60 hertz, so it will automatically change the potential from 0 to 80 volt periodically. Okay, now let's start collect. Okay, so this is the how the signal looks like, and we have in this diagram we see two peaks here. So you want to find out the potential difference between these two peaks, and so you can highlight this one to click stat. You can find the position of the max and the position of the max, and similarly do stat on the other one and stat. So now you can find the difference between the two peaks. That's the point when the elastic clearance start to happen, and this is another elastic clearance start to happen. So the potential difference between here, that will be the ionization energy level.